Ladies and gentlemen, welcome to this episode of my tutorial video series. This is part 4 of advanced problems and solutions on production function. The problems on production function will be provided to you in a number of parts, and in each part I will solve one or two inclusive problems. In fact, problems on economics are mostly solved by using calculus, and I will provide to you problems and solutions on demand function, cost function, market equilibrium, consumption function and production function. Okay, and each part you will find one or two inclusive problems. So in this episode I will solve one problem on production function. A production function is given, which is q equals to root over k into L, w equals to 3, r equals to 6. The question is compute the minimum cost of producing 100 units. K is capital, L is labor, W is wage rate and R is cost of capital. Now cost of capital means weighted average cost of capital or WACC. That means this includes both equity capital and debt capital. So on the basis of this data, we have to find out the minimum cost of producing 100 units. So let's get into the solution of the problem. I am doing the solution here. Please look at the whiteboard. Solution. The production function is given by q equals to root over k into L equals to k to the power half L to the power half. So the production function is q equals to k to the power half L to the power half. Now MPL, that is marginal productivity of labor, is equal to del Q del L is equal to DDL of k to the power half into L to the power half. So we are differentiating Q with respect to L to find out the marginal product of L. So this becomes, we are differentiating k to the power half into L to the power half. So this becomes half L to the power half minus 1 into k to the power half, which is equal to half L to the power minus half into k to the power half, which is equal to half k to the power half divided by L to the power half, right? So marginal productivity of labor is half k to the power half divided by L to the power half. In next step, we shall find out the marginal productivity of capital, that is MPK. MPK equals to del Q del K. That means we are differentiating Q with respect to K, keeping L constant. So this is DDK of k to the power half into L to the power half, which is equal to half k to the power half minus 1 into L to the power half equals to half k to the power minus half into L to the power half, which is equal to half L to the power half divided by k to the power half. So we have differentiated Q with respect to L to find out the marginal product of labor, and that is half k to the power half divided by L to the power half. And in this step we have differentiated Q with respect to K to find out the marginal productivity of K, and which is equal to half L to the power half divided by k to the power half. Right? Now at equilibrium, the ratio of marginal productivities is equal to the input prices, ratio of input prices, that is MPL by MPK equals to W by R, when W is the wage rate and R is the cost of capital. So at equilibrium means where the iso cost line is tangent to the isoquant. So we have to find out this point mathematically, right? The producer is in equilibrium at the point of tangency between isoquant, that is IQ, and the iso cost line, that is IC. Here we measure labor, and on y-axis we measure capital. On x-axis we measure labor, and on y-axis we measure capital. So this is the equilibrium point of the producer. So the producer is using this much of labor and this much of capital. So we have to find out mathematically this point given this production function. Okay? So at equilibrium, the ratio of marginal productivities is equal to the ratio of input prices. That is MPL divided by MPK is equal to W by R. Now, at equilibrium, MPL divided by MPK equals to W by R. W is wage rate and R is cost of capital. So what is MPL? Half K to the power half by L to the power half. So this is half K to the power half divided by L to the power half. And what is MPK? MPK is half L to the power half divided by K to the power half. So half L to the power half divided by K to the power half. Right? So this is equal to how much? W by R, and W is given as 3 and R is 6. So this is 3 by 6 or half. Right? So MPL by MPK is equal to half given this production function and the values of W and R. So half cancels out each other. What remains? K to the power half divided by L to the power half whole divided by L to the power half divided by K to the power half. This is equal to half, that is 3 by 6. This means K to the power half divided by L to the power half into L to the power half K to the power half divided by L to the power half equals to 1 by 2 or half. Now K to the power half into K to the power half equals to K, that is root over K into root over K equals to K. This gives K by L to the power half into L to the power half is equal to L, that is root over L into root over L equals to L. So K by L equals to 1 by 2. This means 2K equals to L. So we have found out 2K equals to L. Now the production function is Q equals to KL. Therefore Q equals to KL root over KL equals to K to the power half into L to the power half. Now we know L equals to 2K. So in place of L we put the value of L as 2K. So we get this is equal to K to the power half into 2K to the power half. So K to the power half into 2K to the power half Now this is what? This is 100 because we have to produce 100 units. So this is 100. This means k to the power half into k to the power half equals to k, and 2 to the power half means root over 2. So this part becomes root over 2 into k equals to 100. Therefore, k equals to 100 by root over 2 equals to how much? Let me use the calculator. What is the value of root 2? It's 1.41. So we divide 100 by 1.41. 100 divided by 1.41, that gives us 70.92. 70.92. So this is the value of k. So k is 70.92. What we have done? We have differentiated q with respect to L to find out the marginal product of L, and we have differentiated q with respect to k to find out the marginal productivity of k, and at equilibrium MPL by MPK is equal to the input price ratio of input prices, that is MPL by MPK equals to W by R. We have put the values of W and R here, and we have found out 2k equals to L. Now the production function is Q equals to root over KL. So we have put the value of L here, taking Q as 100 because we have to find out the minimum cost of producing 100 units. So here Q equals to 100. So we have put the value of Q as 100, and we have found out K equals to 70.92. Therefore L equals to how much? L is 2k, that is 2 into 70.92, that is 70.92 into 2, 70.92 into 2, this gives us 141.84. 141.84. So we have got the values of k and L. The value of k is 70.92 and the value of L is 141.84. So now we have to find out the cost of producing 100 units by deploying this much of capital and this much of labor. So the cost becomes minimum cost equals to how much? L multiplied by W plus K multiplied by R, that is amount of labor into wage rate plus amount of capital into cost of capital. This gives us the total cost of producing 100 units. So we put the value of L, W, K and R. What is L? L is 141.84. So we write here 141.84 into W is how much? 3. We write 3 plus K into R. What is the value of K? 70.92. See here 70.92 into R is 6. So this is the minimum cost, 141.84 into 3 plus 70.92 into 6. So 141.84 into 3, that gives us 425.53. So 425.53 plus 70.92 into 6, 70.92 into 6. This gives us exactly the same figure, 425.52. That means the cost of capital and cost of labor, that is total wages, are same, 420.53. So into 2 it becomes 851.04 equals to 851.04. So this is the minimum cost of producing 100 units given this production function and given the wage rate as 3 and cost of capital as 6. Right? So this is the complete solution of this problem. What is the problem? The problem is a production function is given, that is Q equals to root over KL, W is 3, that is wage rate is 3, and R, that is cost of capital, is 6. Now we have to find out the minimum cost of producing 100 units. So first, what we have done, we have differentiated Q with respect to L in order to find out the MPL or marginal product of labor, which has become half K to the power half by L to the power half. In the next step, we have differentiated Q with respect to K to find out the marginal product of capital MPK. So MPK equals to half L to the power half divided by K to the power half. Now at equilibrium, that is at this point where the IQ is tangent to the IC, this is the equilibrium point of the producer. So at equilibrium, the ratios of marginal productivities is exactly equal to the ratio of input prices, that is MPL divided by MPK will be exactly equal to W by R, and we have done that here. MPL by MPK equals to W by R. Now we have put the value of MPL, that is half K to the power half by L divided by L to the power half. The whole thing divided by MPK, and what is MPK? Half into L to the power half divided by K to the power half. Half cancels out each other, so remains K to the power half divided by L to the power half. The whole thing divided by L to the power half divided by K to the power half equals to W by R, and W is 3 and R is 6, so 3 by 6 gives us half, 1 by 2. Right? So from here, putting the values of W and R, we have found out 2K equals to L. Now we have put the value of L here, that is in the production function. We have to produce 100 units, so Q becomes 100 here. Q is 100. So K to the power half into 2K to the power half equals to 100, because 2K equals to L. So we have found out K equals to 70.92 and L is 2K, that is 70.92 into 2, that is 141.84. So we have found out the values of K and L, which will give the point of equilibrium, that is the point of tendency between IQ and IC. So in the next step, we have to find out the minimum cost of producing 100 units by deploying this much of labor, 70.92 of labor, and this much of capital, that is 141.84. And the cost is L multiplied by W plus K multiplied by R, when W and R are wage rate and cost of capital respectively. We have done that thing here. 141.84 into 3 plus 70.92 into 6. So that gives us 851.04. That is 851.04 is the minimum cost of producing 100 units given this production function where W equals to 3 and R equals to 6. Okay, so this is the complete solution of this problem. I hope you have understood this solution. Still, should you have any doubt in your mind, should you have any query in the back of your mind, please feel comfortable to let me know through the comment section so that I can provide you the solution to those doubts and queries. And if you think the video is useful and meaningful for you, please do share the video with your friends and brothers and sisters. And I will also request you to like and subscribe my channel so that I am motivated to provide more videos, more useful and meaningful videos. And finally, thank you very much for your precious time. Stay well and goodbye.